Hi Mickey, how's it going? I told you I'd read you a story the other night, but just in case, I decided to go ahead and make a recording of it and send it to you so you could. Sorry about the little bit of fan noise, but everything will be okay. Not the best background, obviously. There's no stuff in the background. But anyway, I wanted to read you this book tonight, and it's called "Discovering the Speed of Light." It's actually one of the books that I believe your favorite person, excuse me, your favorite physicist or astronomer is quite fond of. So anyway, without further ado, I better go and read you this story before it's too late, okay? So we're going to go and skip past the introduction and go right over to the actual introduction. I'm sorry. Introduction. Light, which has existed long before humans populated the Earth, will continue to do so long after they are gone. It is one of the most intriguing and important subjects that has ever been studied. And the people who have studied it range from ordinary people looking up to the night sky to some of the greatest minds of all time. The speed of light is one of those mysteries that have intrigued scientists for centuries. History tells us that the first recorded attempt to measure the speed was made by an Italian scientist of the Renaissance, Galileo. Before him, the overwhelming opinion, even in the highest ranks of science, was that it was infinite and therefore immeasurable. Chances are, however, that even in ancient times, astronomers, astrologers, and other inquiring minds, driven by burning curiosity, would have tried to measure it. How far away were the sun, the moon, the billions of stars? How far away were the other planets? Was it possible to measure the distance? If so, how? Today we know that light from the sun takes around 8 minutes to reach Earth through the research of not just one, but many inquiring minds. And over the span of several hundred years, in modern times, scientists apply this discovery to new technology. Even today, researchers are continuing to explore ways to harness light and its energy. For example, right now they have something called the beta particle drive, and it makes just enough thrust to do this. Actually, my breath has more thrust than the new beta drive, but in space, you don't actually need to have that much thrust because technically, besides gravity, there's not a lot of friction out in space. So you can have these really engines that put out almost no real appreciable thrust, and it'll go and move a huge spaceship. It's amazing. And by the way, in this picture over there, Galileo was the first to try to measure the speed of light. His support of Copernicus' theory of centered solar system got him in trouble more than once with the Catholic Church. Because of the quest for the speed of light cannot be fully appreciated unless it is seen in terms of centuries of misunderstanding about light, this book begins long before the first experiment, which speed took place when men and women still believed that an eye generated light. This book will look at the people who first studied light, the first people who tried to measure it, the people who have applied the science of light to some of the great discoveries of the past, and the people who are studying light and its energy today. So you might remember a little bit of this from his video series. So I think it was like the fourth or fifth one that they were talking about how to measure light, and he was actually measuring the light waves. Pretty cool, huh? All right. Early studies in the science of light, chapter 1. The speed of light was never a major question for science in ancient cultures. Almost everyone believed that the answer was obvious. Light traveled at infinite speed. How could anyone doubt that? The sun rose and its light spread immediately to all visible areas. The moonlight was there and you never saw it coming. It wasn't so surprising a view. The speed of light isn't easily deduced from reflection or refraction, and relatively sophisticated technology is needed for its measurement. This doesn't mean that early cultures such as those in Egypt, the ancient Near East, and the New World has no interest in unraveling the mysteries of light. Here's a picture of it. You can probably see it kind of a little bit. This is actually, it's depicting the Egyptians, and that's one of their gods right here. And there's some, I think that's one of the pharaohs, and these are just regular people right here. They did study its optical aspects. One of the earliest astronomers whose name we know was the Egyptian vizier Imhotep, who lived about 2600 BCE. Archaeologists have uncovered evidence of the astronomical observations by Mayan ruins that date to about 800 CE. And there's some evidence that sites such as Britain's Stonehenge, which dates to the first millennium BCE, may also have been used, at least in part, as an astronomical calendar. Do you know some things that are astronomical? Historians tell us that the first recorded attempts to develop a science of light come from about 550 BCE. From classical Greece, the philosopher Empedocles, for instance, claimed that the eye emitted light to an object and thereby sensed it. So what it's saying is that basically what it's trying to explain is that your eye, right here, is actually the one that makes the light so you can see stuff. But see, if that was true, then why is it that you couldn't see in the dark? So that theory was actually, see what I mean? It takes a little time to go ahead and go over some of these theories. But anyway, but the first two, okay, Democritus, that's the next Egyptian person, I believe. But the first to be truly analytical about the science was a philosopher-scientist, Democritus. Yeah, I think it's Democritus. Democritus? He was born in Abdera in Thrace, in modern-day Greece, though the date of his birth may be 470 or 460 BCE, and possibly even 490 BCE, well, before Christ or something. I think that's what it means. He was born into a noble, wealthy family with close ties to Greece's enemy Zeus, kings of Persia. In fact, it was thanks to Zeus's gratitude that his father's aid and Democritus had a chance to be taught science and philosophy by Persian magi, or wise men. So basically, back in the day, the people who used to teach science and stuff basically were, yeah, I mean, they were smart, but they weren't really scientists or anything like that. They're just people who had a little bit more enlightenment than the others, and that was their job. After his father's death, Democritus became a wanderer, traveling over much of what was then the known world: Egypt, India, and the lands in between. And yes, pretty cool, huh? When he returned to Abdera, he was penniless and supported himself by his wits, giving public lectures on philosophy, on the use of various plants, on such natural phenomena as weather. In fact, Democritus could forecast changes in the weather so well that people began to think he could predict the future. But Democritus didn't want to be a public figure. What he was, first and foremost, was a philosopher, and scientist whose ideas about the physical world were always based on observation and fact. He proposed that the eye consists of water, and that it is able to see because it can mirror light traveling through the air from a luminous object. By mirror, he meant reflect. The way he understood it, air disperses light in just the right way so that the eye can absorb it. Democritus was a lot closer to the truth than anyone of the time could imagine. Images are formed when either generated or reflected light enters the eye. The air, however, plays no part in carrying the images to the eye, nor does the water. They may alter the path of light as it passes through them, causing such things as reflection or reflection. Like, for example, if you go ahead and see like my head right over here, it's actually kind of shiny and you can see my bald spot. So anyway, that's how air and like light and stuff like that can play tricks on it. If there wasn't that much, moisture in here, there wouldn't be such a, you wouldn't see so much reflection. That's basically what they're talking about. Oh, I forgot to show you the name for it, my bad. Magi. So, what is a magi? I'm not sure this now. Magi, also turned up, of course, as the three wise men of the New Testament. The word is the heart of the English word magic, or mage, and magician. And indeed, many did believe that the magi could perform powerful magic. But what the magi of King Zeus' court was teaching Democritus was science, not spells. Now let's see. I don't want to take too long reading this because it's already been 9 minutes. I don't want to take too long with this, but let's go ahead and read the next page, okay? Okay, you're going to love this. Plato and the Theory of Atlantis. Remember that movie that we watched a while ago where they found Atlantis was an underwater city? Plato was also an author who created a controversy that continues to this day. He told of an island whose inhabitants were amazingly advanced in all ways, but which sank beneath the waves. He called this island Atlantis. Was he thinking of the real island? They were now called Santorini, after a volcanic eruption which occurred around 1500 BCE. The center of Thera sank, and much of the rest of it was destroyed. Was Plato telling a true history of the vanishing people of Thera? Or was he just making it all up? Now, that is kind of funny if you think about it. If they were a really advanced society, you'd think they'd leave something behind, right? Who knows? Anyway, uh, so the next thing I was going to go ahead and do, which is really cool. Okay, early light speed measurements. I'm just going to go start with the first chapter, and then after that, we're going to call it a night, okay? Because I do want you to get some sleep. Oh,